Let us deal with the second problem in this segment. The second problem is problem number 5.270. The problem is stating a voltage applied to an X-ray tube being increased 1.5 times the short wave limit of an X-ray continuous spectrum shifts by 26 picometer. Find the initial voltage applied to the tube. So if we begin with this problem, we need to understand a few concepts which I am repeating over here. So if we consider that the energy equation E equals hc by lambda, so we can clearly understand from here that if we increase the value of wavelength, the value of energy will go down, and the reverse is also true. So over here for X-rays, the energy is in the form of electron volt, which is equal to hc by lambda. In this case we are taking this one as lambda naught corresponding to the initial value. Now the question is stating when there is a change, the value of voltage is increased to 1.5 times. So 1.5 times EV. So this is case 1, equation number 1 that we have. And in this second scenario we are saying that the voltage applied to an X-ray tube being increased 1.5 times. So if we increase this value to 1.5 times this value, so this will become hc by lambda final. This is the second expression that we have. So as energy is increased, the wavelength is reduced. So over here I can say that the problem is stating that the change in this wavelength or the shift lambda naught minus lambda f is given to us as delta lambda, the value being 26 picometer. So if we substitute the value of lambda naught, it is EV. If we substitute the value of lambda naught from here, it is hc by EV minus of hc by 1.5, that is 3 by 2 EV, and this is equal to delta lambda, and then we can write it as hc by 3 EV is equal to delta lambda. The problem here is asking us for calculation of V. So V can be written as hc by 3E delta lambda. So if we substitute the values, so we can say V is equal to 6.6 10 to the power minus 34 times 3 into 10 to the power 8 divided by 3E. Electronic charge is 1.6 10 to the power minus 19, and the value is given to us in picofarad. So 26 picofarad can be written as 10 to the power minus 12. So we have all the values in SI unit, and on solving we obtain this as 15.8 into 10 to the power 3 volt, which we write approximately as 16 kilovolt. So this is the answer for this problem, 16 kilovolt.